Assalamualaikum and hello. We are from Group 5, Section 10. We are going to explain about our final project of mechanic machine. I'm going to introduce myself and my teammates. My name is Zul Iman bin Hamzah. My teammates are Muhammad Sharul Izuddin bin Cik Ros, Muhammad Alim bin Zakaria, Muhammad Afiq bin Hassan Nusi, and Muhammad Irfan bin Saiful. We are required to design a power transmission system for a ball milling machine for Company A. I'm going to explain about the introduction, which is milling. What is milling? Milling, or also known as machining, is a process of machining using a rotary cutter to remove material through contact of cutter towards workpiece. The milling process can be done with varying direction on several axes, speed of cutter and pressure. Different from a drilling machine, the milling tool moves along its rotation axis and moves perpendicular to its axis so that the cutting process can occur. For a ball milling machine, it is a mechanical technique widely used to grind material into fine particles and also blend material. Being an environmentally friendly and cost-effective technique, it has found wide application in industry all over the world. A ball mill is used to process many materials such as gold, silver, copper, ceramic, and many more. It is commonly used for the production of cement, silicate product, building material, fireproof material, fertilizer, and including glasses. A ball mill consists of a hollow cylindrical shell rotating on its axis. The axis of the shell may be either horizontal or at a small angle horizontally. The machine is filled with balls which are made from steel, stainless steel, ceramic, and even rubber. There are many types of grinding media that are used during the grinding process in the ball mill. The media of grinder can affect the material being ground. As shown in figure 1, it is a bigger ball milling machine, while figure 2 shows a ball milling machine which is a small version of it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sharul Izuddin bin Cik Ros. Now I will talk about the case study of this project. Alright, for the transmitted power bed driver system, basically the arrangement of bed driver system is conceive driver, driven, and belting. So driver, we can call it as a motor, and driven is like a shaft or pulley. Then belting is a belt. Right, so power is transmitted from the driver sheath by means of a belt to the driven sheath. A belt is a loop strip of flexible material used to mechanically link two or more rotating shafts, while the pulley is a wheel with a groove between two flanges around its circumference. Right, these both related will be used in the transmit power in the belt driven system. So when we look at the uh, figure there, so belting and pulley, and got one other is shaft, and the shaft will connect to the driver, which is motor, and then when the motor is rotating, the shaft will rotate the pulley, and then the pulley will rotate the belt and connect the belt that connect with another pulley will rotate the another pulley. So power transmitted from the driver to driven sheath depends on factors such as speed of the belt itself, surface of the contact between the belt and the sheath, and workspace constraint where the belt driver is used. So the objective in this project is to determine the motor power and radiation mode ratio. And then the second one is to calculate efficiency of the bed driver system. In this project, the type of bed has been considered is flat bed system. We use it because it's very easy and have a lot of the advantages of this type of bed. So that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alim bin Zakaria. with metric number CD200187. And now I will present about calculation for this report. So we go through the content of this calculation. So we have been given a task by lecturer from report instruction, which is we have to applying an analytical method to solve the problem, which is the real problem in life. So we apply the method that we have been learned in the class. So from the task, we need to select the proper transmission system. So we have been choose the belting system drive for our report, and we use the flatbed for the calculation. And we also add another question for this calculation. So we go through the methodology of calculation. First of all, from the task being given, we have output torque required at mill, which is 1000 Newton meter, outer diameter of mill 2000 millimeter, and the angular velocity, which is 15 RPM. So I will separate for my answer to find what is the power transmitted, the efficiency, and the length. So this is for our calculation. As we can see here, we go through the formula that we have discussed, or that have been present from my friend from the case study. So this is the calculation, and we start from the tension both sides. So um, we use the information that given from the task, and we substitute into the formula, and we get the equation first and the another equation to substitute again, and we get the T1 and T2. So from the T1 and T2, we can substitute in formula of power transmission, which is P is equal to T1 minus T2 multiplied by V. So V is equal to omega R. Then we get the power transmitted. We get P1 and P2. Then we get the efficiency. So the efficiency, as we can see here, and is equal to 2.34 percent. So another question that we have substitute is the length of belt. So from the information that we have been calculated, so we input for this formula length of belt, and we get the answer for the length of bed for this calculation. So next, we have been discussed about the calculation. For this calculation, engineer or designer engineer must know how to relate between the engineering problem that face in the real life to the analytical subject that we learn from the class or any book. Then the calculation is one of the strategy in any project to determine the objective of this project. And based on this calculation that we calculate before, it's shown is about the power proper transmission system, which is we use the belting system drive to install at the rotational ball molding from the task given from the instruction report. And we find the power transmitted using the belting belting system method, and we find the power transmitted, we find the efficiency, and also we find the length of belt. So as we can see here, the maximum power transmission formula, P is equal to T1 minus T2. Actually have multiplied by V, but I forgot to put. And also we get the velocity of bed calculate was 13.08 milli per second, meter per second. And also we get the power need to the belting go through the rotational ball milling, which is 3.272 kilowatt. After we substitute all the tension formula into the formula of power transmission. So that's all from me for the calculation of this report. So thank you.
Assalamualaikum, my name is Muhammad Asif and today I will continue the presentation of our group about the analysis. So for the analysis, there is a few parameters that we need to be considered, which is space constraint, working area humidity, installation cost, engineering solution technology, and the maintenance cost. So as for the parameters, the first one is the space constraint. So for the space constraint, we need to maintain a clean environment and the transmission system operational protection. So the transmission mechanism including the motor and the reducer should be removed from the grinding area and the transmission gear space should be established. It is possible to employ an open type engine which simplify machinery maintenance and repair. So for the second one, working area humidity. So during the ball mill being used, up to 80% of the energy produced in the mill is dissipated as heat. For example, if heat sensitive product are generated that will decay at high temperature, or if side reaction are favored at temperature measurement and control in ball mill is required, then we can maintaining a typical working environment temperature is likely to bring considerable benefits. So for the third one is the installation cost. A good installation would pay off in the form of lower maintenance expenses for many years. Installation and grinding are both inexpensive. There is a lot of money that may be saved and used for the other things. So the fourth one is the engineering solution technology. So as for the ball mill machine, it uses high-tech manufacturing in general. We refer to the cutting-edge innovation that are used to produce high-quality precision engineered part and mechanical assemblies that have a game-changing effect in the industry. So the last one is the maintenance cost. The maintenance cost is for the ball mill. We can do the maintenance for the machine by following the schedule of the date that we need to be for the date that the machine need to be maintained. And when doing the maintenance, we can save thousands of dollars and hours in the process and keep the ball mill clean and keep it run at its best. That's all for me for the analysis. Thank you.
Assalamualaikum. My name is Muhammad Irfan bin Saiful. So right now, I'm going to talk about the conclusion of this project. So first of all, the thing that we can conclude is about the analyzation of the power output. So just for you know, the higher the power output, it will make the powder materials production will be much more efficient or systematic, where it is in compared to a much lower output power of a machine. Secondly, it is about the analyzation of the transmission system of the machine itself. So the thing that we need to be considerate is about the bed drive, the velocity and the maintenance of the machine itself. And then, just so you know, this ball mill machine is considered as a industrial friendly machine, as it is quite common use in Malaysian factory, just like Fakrabahad, because they use it to process the biomass of oil palm. And then the final conclusion of this report is that we have achieved the objective of the study of the ball mill itself, because we know the factors, some of the factors that might influence the machine in good terms or bad terms. So finally, we know that we need to apply the correct way to use the machine, so the machine can last longer. So I think that's all for me. Thank you.
Thank you.